This example will show you how to solve a situation where you have a pipe that's closed at one end. So we have this pipe and we're trying to figure out how long of a pipe we need to produce the 1400 hertz sound, and we also know the temperature of the air in which we want to produce the sound. So the first thing that I'm going to do is just figure out what's the velocity, because I know that the velocity of sound in air is 331.5 degrees Celsius plus 0.6 times the temperature. And since the temperature is 20 degrees, all I have to do is just plug that in. So it's 331.5 degrees Celsius plus 0.6 times 20 degrees Celsius. And that will give us, if I just figure this out really quickly, 331.5 plus 0.6 times 20. That gives us 343.5 meters per second. So that's the first thing. That's the speed of sound. Now the next thing I need to do is to figure out what this pipe is going to look like. So if I have this pipe, let's say here are the two ends of the pipe. So here's the pipe. Let's say this end's solid like that. If I were to produce a 1400 hertz sound, if this pipe is closed, I know I'm going to have a fixed end on one end of the pipe, and I know I'm going to have an open end on the other. So I need to have a node on the one end, I need to have an antinode on the other. And the way I can create that, the most fundamental way I can create that is just by a half loop. So if I were to draw in my half loop, this is what I have. And since I know that I have 1/2 of a loop, that's going to be 1/4 of a wavelength. So it's really important to understand that this half loop here is going to be 1/4 of a wavelength, which means that if I were to just look at the pipe, that's length L there, I know that the length of the pipe is going to be 1/4 wavelength. Now that's important because that's going to help us to figure out exactly what we need to produce the sound. So the next thing I'm going to do is just use my wave equation. So the velocity equals the frequency times the wavelength. Now I know the velocity is 343.5 meters per second. The frequency is 1400 hertz. And I need to just figure out what the wavelength is. So if I just divide both sides by 1400, so 343.5 divided by 1400, I get a wavelength of 0.245 meters, and that's just rounded to 3 decimal places. That means that this is the wavelength of my 1400 meter sound. So if I know that in my tube I only have a 1/4 wavelength, that means that the length is equal to 1/4 of that wavelength that I'm looking for. So the length of this pipe is just going to be 0.245 divided by 4. Which is going to be 0.06125. I'll just expand it all the way out. Meters. That's the length of the pipe that will produce this sound. So that's really what you have to do. And I think the key thing in these problems when you have your open pipe, your closed pipes, is instead of trying to remember, well, how many nodes do I have, how many antinodes do I have, just draw a simple picture. If you draw it out and you just see, okay, I have a half loop, then that'll help you to figure out how many wavelength you have, and you can just use your wave velocity equation in order to figure out how long of a pipe you actually have. That's probably the most fundamental way to solve these different problems.